Hello, we are back with Chapter 4, Proportional Relationships. Today we're discussing Lesson 5, using similar figures. So to get started, if you know, you absolutely know that two figures are similar, so you know that two figures are similar, you can use proportions to find unknown lengths of sides as well as find unknown angle measurements. So there's two things you can do if you know that two figures are similar. The first thing you can do is use proportions to find lengths, unknown lengths, so things you don't know, and you can find unknown angle measurements as well. So the first thing is find the length of sides. The second thing is find angles. And that's only if you know that two figures are similar. So we're going to look at a few examples here. So number one, what it's telling us for this example is the triangles are similar. So boom. Because we know that the triangles are similar, now we can use proportions to find unknown lengths, and we can find unknown angles because we know that they're similar. Now on this figure, if you look on your page, there's not a D. I need you to just go ahead and write a D in right here. For some reason, the vertex just didn't show up. So just go ahead on your drawing and make that vertex D. So we have vertex A, B, and C, and then vertex D, E, F right here. So we're just going to go ahead and figure out which sides are corresponding. So let's go ahead and start with the biggest side. So the biggest side of the big triangle would be here. This is the biggest one. And that corresponds with the biggest side over here, which would be this one. The smallest side would be, well, it looks like it would be this one, and so it would be those. Those would be the smallest sides there. So those would correspond. And then this would be the side in the middle here. Okay, so those are the corresponding sides. So when we look at this, it says side AC corresponds to, so AC is here, AC corresponds to DF. Okay? And then let's look here. Side AB, where's AB? AB is right here. AB corresponds to DE. And side BC, the small one, corresponds to side EF. Okay? So I don't know if you noticed or not, but on the big triangle, there is an unknown variable, which is right here. That is N. And so what we're going to do is that's an unknown length. Since the triangles are similar, we can use proportions to determine what that value is for N. And this is how we're going to do it. So we can either use the biggest side or the medium side because we have a value here and here, and we also have a value here and here. So we just have to pick one. I think I'm just going to go with the big side. So I'm going to use this value and this value. I'm going to use my big triangle on top. So it's going to be DF over AC. That is proportionate to the big triangle EF over the, right here, BC, the smaller triangle. And that's how we set up our proportion. Now we're just going to plug in the values. So DF is 15 over AC. AC is 5 equals EF would be right there. That's the unknown value. That's N over BC, which is 3. So there we go. We have our proportion. Now we can just solve it to figure out what N is. Now we're trying to get N by itself. Okay, it's not by itself. Right now it's being divided by 3. So we have to do the inverse operation of division, which would be multiplication. So we're going to multiply both sides by 3. Those 3's cancel out. They become 1. We have 1 times n, which is just n. Over here, we look to cross cancel. We can't cross cancel, so we're going to multiply across. 15 times 3, I'm going to take that off to the side here. And 15 times 3, 3 times 5 is 15. Carry the 1. 3 times 1 is 3, plus 1 is 4. So that's going to be 45 over 1 times 5 is 5. And then I'm going to reduce this. 45 and 5. 5 goes into 45. It also goes into 5. 5 goes into 45 9 times. 5 goes into 5 1 time. So I end up with 9 over 1 equals 9, or n equals 9, which is the same thing. So that's how we use proportions to find the values of unknown sides. So the unknown side here would be 9. All right, cool. The other thing it talked about, so we're going to be using this a lot. The other thing it says is we can use similar triangles to figure out the unknown angles as well. So if we look, the unknown angle would be right here. It's x, right there. That's the unknown angle. So we're going to figure out, well, which angle is corresponding with x. And if you see x is in between the pink and the yellow, that's the big and the medium side. And over here, it's between, the angle is between the pink and the yellow as well. So that means that angle A and angle D are corresponding angles. So since A corresponds to angle D, so since angle A corresponds to angle D, that means they're equal in measure. So if D is 35 degrees, that also means that X is equal to 35 degrees. And there's a little degree mark right there. So X equals 35 degrees. Well, there you go. That's how you do those. So let's go ahead and work on a couple more. We're going to find the unknown measure in each pair of similar figures. So it's telling us that these triangles are similar. So we can do two things. There's number 2. We can do two things. We can find the unknown side, or we can find an unknown angle measure. Okay? So when we're looking at this particular example, the unknown side, it's an unknown side. So that's what we're going to do. We're going to be using the side lengths to make a proportion. Here, we are going to be, the variable is in the angle. So that's what we're going to be doing, is finding the unknown angle for that problem. So let's go ahead and get started. When I'm doing this, I always just like to start with identifying the corresponding side. So first I'm going to identify the biggest side. So the biggest side out of these would be VW. And the biggest side here, even though we don't know this one is similar and the shape is the same. And so I'm going to say that this one is the biggest here. So those two sides correspond. And then I'm going to highlight the smallest side, which would be right here out of these three. UV is the smallest, which means MN is the smallest there. Those are corresponding. And finally, the one in the middle would be right here, UW. Okay, and that's where you see our variable right there, okay? So we have to set up a proportion. So when we're doing this, we can either use this set of corresponding sides or this set of corresponding sides. We have to use this one that has a variable, so that's going to be on one side of our equation. But it really doesn't matter if we use this one or this one. So I'm just going to go ahead and use this one just because they're smaller numbers. And, you know, I'd rather work with smaller numbers than big numbers. So I'm going to put the big triangle on top. So I'm going to start with this side. UV over MN. So the big side, big triangle over the small triangle, MN, is equal to, and then I'm going to do the corresponding side with the unknown measure. So the big triangle on top, so UW over MO. All right, now that I have that, I'm just going to go ahead and fill in the numbers. So UV is 12. So I'm going to plug in 12 right here. 12 over MN is 6 equals UV. UV is 20. And then MO is X. MO is X right there. So we have a proportion. What I notice right now is the variable is on the bottom. And whenever the variable is on the bottom, I can't figure out what it is. So I need to go ahead and invert this entire proportion. So I'm going to go ahead and flip it. So everything that's on the bottom is now going to flip to the top. So I'm going to invert it. I got 6 equals X. This was on the bottom, now it's on the top, and everything on the top is now going to go to the bottom. 12 over 20. Okay, so now X is in the top. I can figure out what it is. So I need to get X by itself. Right now it's not by itself, so I need to, 20 is on the side. 20 is related to X through division. So I have to do the inverse operation of division, which would be multiplication. So I'm going to multiply both sides by 20. Okay, those 20s cancel out and become 1. 1 times X is X. Voila. We have X by itself, which is exactly what we want. Now I'm going to I'm multiplying fractions, so I'm first going to look to cross cancel. So I can't do anything with this 6 and 1. I'm going to look at the 20 and the 10. Do they have any common factors? And the answer is yes, they do. Let's see here. What is the common factor? I'm going to say both of them, there's a common factor of 4. So 4 goes into 20 5 times. 4 goes into 12 3 times. Now we're just going to multiply across. 5 times 6 is 30 over 1 times 3 is 3. And then we can just reduce this. 30 divided by 3 would just be 10. So that's 10. So X equals 10. So that is the unknown value. X equals 10. Okay? So let's go over here to problem number 2. And I'm just going to kind of do the same thing with the biggest side, smallest side, medium side. So let's go ahead and figure out what we already know that they're similar, right? So the biggest side here on the biggest triangle is 16. Right here. Okay, the biggest side here out of 6, 9, 12 would be right here. So that's the biggest side, right there. Let's go ahead and do the smallest side. So the smallest side on the big triangle would be 8. The smallest triangle, the smallest side on the small triangle would be 6, okay? And then that leaves us the one in the middle. So that would be right here. And right here. So the variable, the unknown value that we're trying to find is the angle measure. So I'm trying to figure out, well, what angle corresponds with that one? And it's easy to see that this angle has the pink side, which is the biggest side, and the yellow side, which is the one in the middle, around it. And over here, R has the biggest side, which is pink, and the medium side, which is yellow, around it. So that means that these two angles are corresponding angles. Okay? Which means they're the same. So angle F is congruent. I'm just going to say, it corresponds to angle R, which means they're congruent, and you'll learn about this later. It just means they're the same or they're equal. So angle F is congruent to angle R, which means that these angle measures are the same. So if angle R is 29 degrees, that means that K is 29 degrees. So K equals 29 degrees. So there you go. There's the unknown value. Okay, let's go ahead and turn the page and look at these next 2 examples. So now we're dealing with 2 quadrilaterals. So let's go ahead and find the unknown values here. Now, we already know that they're similar, okay? So we know that these are similar figures. That means we can find the unknown sides and also the unknown angles. So in this picture, the unknown side would be right here, y. Now, if you see, this corresponds with that side there. So these two sides are corresponding. And then you can see that this smaller side here corresponds with this one. And so that's really all we need to set up our proportion right there. So we need one set of corresponding sides where both of the values are there, like right here. And then the other one needs to have where one of them has the variable. So let's go ahead and set it up. So I'm going to write the big rectangle is going to be on top of my fractions and the small rectangle is going to be on the bottom. So I'm going to start with the corresponding side where I have both pieces of information right here. So that's going to be WZ over AD. And that ratio is equal because they're similar to this big, remember I have the big rectangle on top, so that's going to be WX over the side that corresponds to that, which is AB. Now that I have my proportion, I'm just going to go ahead and fill in the numbers. So WZ is 9, so I'm going to put a 9 here. 9 over AD, which is 5, is equal to WX, which is Y, over AB, which is 15. Now I have my proportion. I'm going to go ahead and try to figure out what Y is. To determine what Y is, I have to have Y on this side of the equation by itself. And right now it's not. There's a 15 over here. So Y is being divided by 15. So I have to do the inverse operation of division, which would be multiplying both sides by 15. Okay, so once I do that, these 15s cancel out and they become 1. 1 times Y is just Y. And now I have Y by itself, which is exactly what I want. I'm going to go over here and simplify this, make this 15 over 1, which is the same thing as 15. Now I'm multiplying fractions, so I'm always, whenever I'm looking to multiply fractions, I always look to cross cancel first and then multiply across. So let's look to cross cancel. The 1 and the 9, I can't do anything there. But what about the 15 and the 5? I can. They both have a common factor of 5. 5 goes into 15 3 times. 5 goes into 5 1 time. And so now I'm ready to multiply across. 3 times 9 is 27 over 1 times 1, which is 1. So 27 over 1 is the same thing as just 27. So we have Y equals 27. That is the unknown value. All right, cool. Let's go over here to problem number 4. Now, the problem already states that these figures are similar. So if you look and you see the unknown variable that we're trying to find, the unknown value is this S right here. Okay, that's what we're trying to find. Now, with similar figures, the angles are exactly the same, the corresponding angles. And if you can see, we have a big angle here, a big angle here, which are the same. And right here, we have a big angle and a big angle there. Here, these are smaller angles, and they're and a small angle there, which is the same. Okay? So if I'm going to look at this, these are the same. This is my big angle. This is my other big angle. So the big angles are going to be the same measure as the big angles over here and the big angle over here. Okay? And also, if you look, the small angle, which is this 58 degrees, is the same here as this small angle. And that also means that these small angles in this similar figure are going to be the same. They're also going to be 58 degrees. But we're not really worried about that. I'm just giving you that extra information. The only thing we're concerned about is this S. And this S is a part of one of the big angles, which is going to be the same measure as the big angle over here, which is in the because they're similar. So we're just going to say S equals 122 degrees. So that's the answer to problem number 4. All right, good job. We will see you next time. Bye-bye.